Hello everyone, welcome back. In this video tutorial, we are going to look at how to detect multicollinearity in SPSS, and we are going to be looking at three different methods: the variance inflation factor, the tolerance, as well as the matrix approach. Please, if you are just coming across our video for the first time, this is the official YouTube channel of Lightway Research and Technology Center. Kindly click on the subscribe button below to be part of this great channel. Also, you can top up our video. If you have any question, you can also make it clear in the comment section of this particular video. Okay, before we look at how to do this particular test in SPSS, I want to take you through the hypothesis statement, the decision rule, and what multicollinearity means. Multicollinearity tests whether independent variables in the regression are too highly correlated with each other. Please take notes, when we are talking about multicollinearity, well, our focus is on the independent variable. We are not concerned about the relationship between the dependent and each of the independent variable. Of course, we expect the relationship to be very strong. The relationship between the dependent and independent variable. But the relationship between two independent variables must not be very strong. It should be below certain threshold. If you are using a tolerance approach, if you are using VIF approach, or if you are using the matrix approach, there are certain threshold that the value must not cross, which we are going to look at in this particular video tutorial. So severe multicollinearity inflates standard errors, make it very difficult to access the unique effects of each of the independent variables on the dependent variable. So please always check for this particular issue and make sure you address it if there is any concern. Multicollinearity is also one of the assumptions of linear regression. Now, the hypothesis statement is very simple and straightforward. The non-hypothesis says that there is no problem of multicollinearity among the independent variables, that is predictors, while the alternate says that there is a problem of multicollinearity among the predictors. In other words, there is a very strong relationship among the predictors. And the decision rule is very straightforward. If you want to make use of tolerance to determine whether the problem exists or not, then you must ensure that the value is greater than 0.10. When the tolerance value is less than 0.10, then there is a problem of multicollinearity. That simply means that multicollinearity problem exists. Also, if you want to make use of VIF, you must ensure that the value is below 10. Of course, you can make use of 5 as well if you want. So when the VIF value is above 10, it simply means that there is a problem of multicollinearity. And if you want to be very strict, you want to increase the standard of your paper, then you can make use of 5 for VIF and 0.2 for tolerance. Another approach is the condition index, which is not very common. So this one says that when the condition index is greater than 30 with high variance proportion across the predictors, then there is, and that it shows that multicollinearity problem exists. But the one that is very common, which of course I believe you must have seen in one or two papers, is the correlation matrix, and the threshold, which is also very common. Some use 0.9, but the common one is 0.80. So when the value exceeds 0.8, it simply means that multicollinearity problem exists. But when it is below 0.8, even if it is 0.79, that shows that there is no problem of multicollinearity. So you need to memorize this decision rule, or you can just write it down anytime you need this. You just take it, then you compare and make your interpret the results. So now let me take you through how to do this particular test in SPSS. Okay, this is also similar to the last video tutorial that we released, or the video that we uploaded. If you want to do multicollinearity test too, you need to go to analyze. From analyze, you move to regression. From regression, you go to linear. Once you click on this, please take notes. This box will be empty and here too will be empty. So you identify your dependent variable and independent variables as well. Once you identify the the dependent and independent variables, then you move it to the right box. Then the dependent variable is weight. You move it here. Once you do this, then you go to statistics and look for collinearity diagnostics. So you check this particular box. Also, you may check descriptive if you have not done descriptive. If you want to also check test for serial correlation or autocorrelation, then you can also check W1C. But we don't need this. We don't also need descriptive. What we need now is collinearity diagnostics. So once you check this, then you click continue. The next thing is okay, the results will come up. Now we have the regression results here. This is model summary. We are not interested in that. We are also not interested in the ANOVA, the coefficients. Now we have the coefficients and we have the collinearity diagnostics. We have the two. The other one that we didn't have here is the matrix, which I'm going to show you later. Now, if you look at this coefficient table, you will see that the last two columns give us the tolerance as well as the VIF. And don't forget the decision rule. The decision rule is that when the tolerance value is less than 0.1 or less than 0.2, then there is what? Multicollinearity problem. And if you look at the first variable here, current salary, the tolerance value is above or exceeds 0.1 and the VIF is also below 10. So that shows that there is no multicollinearity problem. This variable is okay. If you look at the second variable too, the rent paid by the respondents in the year 2016, the tolerance value is also below 0.10 and the VIF is, the tolerance value is exceeds 0.10 and the VIF is below 10. So now we can conclude that these two variables are not, they are not strongly related. That means there is no problem of multicollinearity. Now another approach you can use is the condition index. If you look at collinearity diagnostics here, you will see here we have the condition index, the third column. This is the condition index, and the condition index says that once the CI is greater than 30 with high variance proportions, which is greater than when the variance proportion is greater than 0.5, then there is what? Serious multicollinearity. Now if you look at the condition index is less than for constant, the first one is constant, the second one is current salary, the third one is rent. So if you look at it, the values of these two variables are less than 30. Each one is less than 30. This is 4.6, which is less than 30. This is 10.16, which is also less than 30. So from here you can say that okay, there's no problem of multicollinearity, but you cannot make your judgments based on this alone. You also need to look at the variance proportions. Then you now look at okay, I said the other time that 2 here is stand for current salary. Then look for current salary, then the proportion, under proportion, what is the value? 0.07, which is below 0.5. Also for rent paid is also below 0.5. So we can say that okay, there is no problem of multicollinearity here. But if you look at the third variable here, it appears that the value is greater than 50. The value here is greater than 50, but there is no cause for alarm. Why? Because tolerance shows that there is no multicollinearity problem. VIF also shows that there is no multicollinearity problem. Then the third approach is the Pearson. This is the variables that we use here, they are all continuous variables. So the most appropriate techniques to check for the multicollinearity issue is the Pearson correlation test. So now to show the results of Pearson correlation test or to do Pearson correlation test, let's go back to analyze Let's go back to analyze, again regression, then linear. Now let's consider, let me add descriptive as well as parts and partial correlations. Considering, okay, let's check for the results. Okay, you can see now that we have the Pearson correlation test. So if you want to do Pearson correlation test, you can just follow that particular method. Then you look at the intersection here. This is weights, current salary, and this is also weights. This is weights. Weights against weights must give us 1. This is the diagonal line. Then if you look at current salary, this is minus 0.005, which is less than 0.8. So there is no issue. It's simply this value is below 0.8. Don't forget the one I showed you here. This is the third approach. Yeah, we can only say there is multicollinearity problem when the value is above 0.8. But if you look at it here, you will see that the value here is what? Is below 0.8. Look at it, trace it here, is below 0.8. That's weights, the dependent variable. Okay, sorry, this is the dependent variable. Let's check for the independent variable. Okay, now the independent variable, current salary as well as rent paid by the respondent. This is it, current salary. This is above 0.8. Please take note, this is above 0.8. Weight is the dependent variable, so we are not interested in that. We are not interested in the relationship. Of course, the relationship between the dependent variable and current salary is very low, but that's not an issue here. What we are after is the relationship between the two independent variables, and the two independent variables here are rent as well as current salary. So when you look at the points at which, the column at which they intersect, then you will notice that the value is above 0.8. So this shows that there is a multicollinearity problem. As a result of that, we cannot be silent about these results. So the conclusion here is that current salary and rent are strongly related. So we need to drop one of the two variables. It's either you drop current salary and make use of rent in your analysis, or you drop rent and make use of current salary. Why? Because the two variables are highly related, and it shows that there is a problem of multicollinearity in the model. So it is always good to make use of different approach. Then you make your decision based on based on the results of the majority. The results of the majority here is that the condition index says multicollinearity problem. Also, the correlation matrix here says multicollinearity problem. So we can conclude that there is a multicollinearity problem in this particular model. Of course, you can also log the variables. If you log current salary as well as rent, this problem may disappear. Now, before I end this video, I also want to show you another way to get this particular correlation table, the Pearson correlation table. In case you don't want to go through the regression channel, you can just go to analyze, then you select correlate, then from there you select by variance by, that's two variables. So now we are only interested in the two independent variables, current salary as well as rent. So once you select these two, you can see here we have Pearson, we have Kindertal, and as well as Spearman. Please take notes, I'm going to do a different video on each of these ones. This one is just like introduction. The Spearman is for categorical variable, while Pearson is most useful for continuous data. Categorical data, Spearman; continuous data, Pearson. So we are going to make use of Pearson because the data are continuous. Then you click OK. This one will also give you the correlation results, and instead of the comprehensive table that this one shows, you have a very straightforward. You can see this is like 1, 2, 3, 4 rows. This one is just like 3 rows, the headings as well as the rows that shows the matrix results, the Pearson correlation results. And here too, you can see two tail. We make use of two tail. I will show you. Let me quickly show you that so that you will not be confused. Here you can see I selected two tails here. That's why we have two tails, and which is the appropriate method. Now Pearson, this is then the number of observation. N here stand for the number of observations. Then now we have rent paid. Then you check rent paid against current salary. Look at it, the value is not different from the previous table, 0.865, and you can see correlation is significant at 0.01 level. if assuming we are looking at the relationship between dependent and independent variable, this particular result is valid, is okay. But multicollinearity is about the relationship between independent variables. So anything above 0.8 is not valid. Is not valid. You need to drop one of the two variables. So please take note of that. Also, you can take the log of current salary as well as rent. When you take the log, you may have a better result. I think I have a log of these variables here. Let me go to analyze again and select log, the natural log of the two variables. Current salary, this square, this is the natural log of current salary. Let me check for the, okay, I don't have the natural log of rent, but let's just take this one and see how the results will look like. Okay, you can see now the correlation drops a bit, 0.822, which is still above 0.8, but the conclusion is that there is a problem of multicollinearity in this particular model. In the next video, I will show you how to address this particular problem and also how to interpret the results perfectly. In fact, I will interpret the results, then you will see it displayed on the screen. Please don't forget to subscribe to our channel, like our videos, and also share with your friends, family. Thank you.